Hi friends, let's continue our discussion on why reinforcement learning is the most suited learning method when it comes to robotics. Yeah. So first thing is reinforcement learning believes in learning from experience rather than looking at static data. It's more dynamic in nature than static. So reinforcement learning is a type of learning where a robot is allowed to explore and gain newer and newer experience. And through this new experience, it identifies what type of actions will give more rewards and what type of actions will give punishments. And this pairs of state and rewards are remembered, and in future the same thing can be exploited. The next issue when it comes to the environment, most of the situations where a robot is dealing with, the environment is almost uncertain. Nothing will be known in advance. Therefore, it becomes very difficult to use training like a supervised training and all that because in advance we won't be knowing what exactly is possible, what exactly happens in the coming future. So it must be able to adapt to all sorts of uncertainty in the situation. And when it encounters any situation, it has to make a decision whether to proceed further or get back or go one side or the other side. So it has to decide what action should be taken for any given situation and to make a optimum decision. Reinforcement learning is the best one. Yes, another problem with AI, machine learning, or data science is a large dimension of input we need to deal with. A lot number of inputs are available, and this high dimensional input makes learning very slow. Collecting all this data along with the result in case of supervised learning or just a collection of all possible data in case of unsupervised learning is almost impossible and cannot be handled in real time. Therefore, only option left is to go for reinforcement learning. So it doesn't require all the inputs at any given time. So at any given time, the current input is taken and the current state is known, and then we'll decide what's the best action to take, and action is taken, and this action will change the state, and the reward is produced, and the reward will be positive or negative depending on the action is the one which we wanted in favor or against. So depending on that action is depending on the action, rewards are produced. Therefore, any given time, a small set of data is being used, and hence, when we are working with a high dimensional data inputs, then reinforcement learning would be the best solution. The next issue we need to look at is about the controlling the motor control actions and manipulation, that is the actuators. So we are working in a multi-dimensional output system. That means the degree of freedom will be very large when it comes to a robot system. Then controlling and manipulating every degree of freedom is again too difficult issue. So it would be easier if we take up through reinforcement learning, like making some action, like making some uh, manipulation and understanding whether such manipulation given a positive reward or a negative reward, and that way we try to learn the better possible manipulation, better possible motor control at different situations. So how much motor control needs to be used, how much pressure needs to be applied on the system that fetches some uh, like arm, and how much rotation needs to be given, in which direction the rotation needs to be given, or which degree of freedom the rotation has to be given. All these issues cannot be taken up with a single time, but through reinforcement learning, it becomes easier and make trial and understand whether it's what right move or wrong move, and that way we learn and try to uh, use the right moves more often and avoid the wrong moves in the coming future. The next one is about autonomous exploration. Yes, as we discussed, when it is trying to adopt for uncertainty, when we don't know the current situation, then we won't be able to decide what is the best way to do, so what is the best action to take. So, in place of trying to find best action when the situation is unknown, the better would be try some random actions and see whether it gives a positive reward or a punishment, and accordingly, we can add new experiences to our knowledge system, and that is done through exploration. And that is possible only through reinforcement learning. And the next thing would be when we are trying to have more than one robotic system in the our more than one robot in our system, then if we want these robots to work in a collaborative way, then the reinforcement learning will be easier to create such a system, like how to make two different things work in collaboration. So we can just make uh, explore and then try to identify the new situations, try to get the new information and understand what type of trial gave a better result, and that adds to the knowledge bank and can be exploited in future. So multi-agent collaboration is possible only through reinforcement learning, and similar action is almost not possible with other two types of learning, whether it is supervised or unsupervised or semi-supervised. Now, looking at the key components of reinforcement learning as compared to the robotics, yeah, we have state, action, space, we have reward function, we have a policy, and we have the value function. So these are the key components involved in any reinforcement learning system. So there is a pair of state and action. So state action space is there. Then for every state action combination, there will be a reward. So how the reward is done, that will be a reward function. Then we have a policy and then value function. So what this means in our robotic version, let us look at it. State. So robot observes its environment. So via sensors, it observes how the environment is looking. If our environment is a tic-tac-toe game, then it sees how many cells out of nine are occupied, how many are free, and find which one is occupied in what cell. So where cross marks are and where not marks are. And if we want to put a not mark in the next, then which cell is more suited and all that to be identified. So for that, first thing, observes the environment. Then policy is the one which decides an action based on the state. So for any given state, what is the best action to be taken is decided by the policy. Action is the one which is executed by the actuators, like placing particular token in any given cell or moving any element from one place to other place and so on. So that is the action taken, and the reward is the feedback provided based on whether action was successful or a failure. So this reward may be available at every action or maybe a delayed one. Like in case of chess, on every step we don't get a reward, but only a reward we get at intermittent steps, like whenever we hit the other uh, elements of other opponent, or if opponent hits us. So these are the rewards we get now and then. So it will be sparsely generated rewards, or even the reward may be at the end, whether it is won or lost. At every step, it may be available, or now and then it may be available, or it may be available only once at the end of the game. So different types of rewards are available. Then the value function is the one which updates the estimates to refine the future decisions. So once we are playing it, yeah, we have played and we have won. Then we must introspect ourselves, what all actions we have taken, what all actions the opponent have taken, and understand for what actions of the opponent, our actions were fruitful, and what actions of the opponent, our actions we make to pay all that. And this value function will help us in updating our decisions, making the decisions better and better with time. The more number of times we play the game, the better decisions we make, the better policy is generated, and hence better actions are taken at every given situation. So that's all about the key components of reinforcement learning. We do have many more issues to discuss on. Keep watching. Thank you. Please don't forget to subscribe and like if you find my videos of some use. Thank you.